Hey there, physics crew, Mr. Spencer here. And what we are doing right now is we're getting started with force diagrams or free body diagrams. And the whole idea behind a force diagram is that you are showing all of the forces that are acting on an object. Okay, and eventually we're going to be able to calculate all of those. But I just want to introduce this idea really fast. So here's a basketball, okay? And whenever we're doing force diagrams, the very first thing we want to do is we want to figure out, is it accelerating or not? So if I'm holding this basketball right here, is it accelerating? Oh. Okay. All right, I think we're okay. Is it accelerating? All right, well, no, it's just staying there. So we know that if it's constant velocity, not accelerating, that we have balanced forces. Well, where are those forces coming from? Well, what we want to do is we want to focus on the forces that are acting on the ball itself, okay? There's a lot of other forces around there, but we're only focusing on what's happening to the ball. So, first of all, I think, okay, well, my hand is holding that up, okay? So that support force is a normal force, okay? But which way is that going? Right? Well, the normal force is acting perpendicular to the surface, okay? So if my hand is the surface, that normal force is pointing up, all right? Now, the next part is, well, what other forces are acting on? Well, I feel this has some weight to it, okay? So Earth is pulling on this due to gravity, so there's some weight involved in this. So which way is that going? Well, it's going in that opposite direction, right? It's not a Newton's third law of force pair, but they are. We do have two forces acting here. We have that normal force going up, all right? And we have the force due to gravity or weight going down. Well, how do those compare? Well, once again, if it's not accelerating, we know that those are balanced. So that means that the normal force and the weight or force due to gravity are equal but acting in opposite directions. All right. Now, what happens if I get rid of the normal force? Well, if I get rid of that normal force, all right, the weight or gravity is still acting on that, still pulling it down. So as soon as I get rid of that normal force, it accelerates, meaning that we have an unbalanced force. And the reason we have an unbalanced force in this case is because gravity is the only force that's acting on it, causing it to pull down or pulling it down and causing it to accelerate towards the center of the earth. Okay. Well, anyways, that is a very brief introduction to things. What we're going to do here is the assignments that are to come are going to help you understand how to identify the forces acting on a force diagram and also how to calculate those. So let me know if you need any help.